Thank you so much for having me. I was excited the entire week for this presentation, and I'm looking so much forward to this half an hour on building web APIs with Rust, State of the Union. Let me quickly introduce myself so that you know what you can ask me and what you can, well, you can ask me anything, but for what questions you might expect some answers. I'm a passionate developer for more than 25 years now. I have my own company. I do a lot of work with Microsoft. I'm an MVP and regional director. That does not mean that I'm on the payroll of Microsoft, not at all. I just do a lot of work with Azure and C# and everything around it, and also Rust, of course, because this is also important in this ecosystem. Beside my professional job, I do a lot of trainings, teaching. I teach one day a week at a local computer science high school. I'm a mentor at the community, especially at the Coding Club Linz, where we run Austria's largest and most active Coder Dojo, which is a programming club for kids. And I'm also a co-founder of the Rust Linz meetup. That's essentially me. So I'm a passionate coder, and therefore I love Rust. I love to code Rust. And for this session, I asked myself, first, why should I do this session and how am I going to approach it? First, why this session? Rust is becoming more and more popular. What I see is that people from other languages and platforms are coming on board. And this does mean that people with other backgrounds from other frameworks are trying Rust. And also, Rust is used in more areas of software development, not just embedded development or system programming, but also application development and also API stuff. Now, if you come to this new platform and you would like to use Rust for building a web API, you have a lot of choices. That's good on the one hand side, but it can also be a little bit confusing. So there are so many great web API related frameworks for Rust, and many people, at least that's my assumption, ask themselves where to start. What should I use? So this session should be a kind of guide through Rust's rich and diverse web API ecosystem. And I have to apologize at the beginning. I present some frameworks which are a personal choice based off personal experiences and opinions. And I would like to apologize even now, immediately, if your favorite framework is not on my list or I don't cover it. That does not at all mean that's a bad framework or whatever. It's just these are my personal choices. How did I go about it? As I said, I've done a personal selection of 4 web API frameworks, well, 4.5, let's put it that way. And if you want to have a more complete list of frameworks, take a look at my slides. Here I have 2 links for you. My selection criteria: the frameworks should be widely used, huge number of downloads. They should be feature-rich for RESTful web APIs. They should be based on Tokyo, because I simply love to use Tokyo. They should build with stable Rust, and of course, a lot of personal interests and preferences. And as I said, we have limited time, so I couldn't do 20 frameworks. I just selected a few of them. So what is our agenda from now on? We will dive into 4 frameworks: Actix, Rocket, Warp, and XAML. I will do a quick intro of the framework. I will show you a little bit of code, only a little bit, because we have so much to cover. And then I'll do a personal statement. And at the end, we'll do a quick closing. That's the agenda for my talk today. Let's see how it goes. With that, without any further ado, let's dive right into the topic. Let's start with Actix. You have the link here on my slides. Please take a look at my Twitter account. I will share the slides later on, and I will also send it to the organizers. So if you want to have them, I'm pretty sure you will find them. They are publicly available on the internet. Now, Actix Web is a well-established and well-maintained framework. It exists for many years, and you get releases every few months. You currently have a stable release, which is 4.2.1, and it's really very feature-rich. If you take a look at the list of features, that's quite impressive. It also includes WebSocket support, which is important for some of my projects. Actix is known to be fast. I didn't do benchmarks because I know that benchmarks depend on many factors. For some people, runtime efficiency is important. For some people, memory efficiency is super important. For some people, developer productivity is super important. So benchmarks is not something where I would like to have some discussions. However, The Actix project is included in the Tech and Power benchmarks, and their numbers are pretty impressive. Check it out. So it seems to be fast. Yeah. And with that, let's dive into the first few lines of code. Let's take a look. So what I did here, let's open it up here. What I did here, I took a sample API and implemented this. This is a sample API, and I implemented it for multiple frameworks. Oh, that was wrong. Here, now you see it correctly. Here you see the Actix framework, the XAML framework, the Rocket framework, the Warp framework, and we will take a look at Spin. So I have no chance to show you everything in this 30 minutes. So please take a look at my GitHub repository. There you can dive into the details and look at all the details of the different frameworks. So let's get started with Actix. The Actix framework, if I scroll down a little bit, as you can see, is based on Tokyo. That's the same for all of these frameworks. Everything starts with an async main, as you can see it here. Logging is built on the log crate, as you can see it here. So you can plug in your own loggers if you want. In my simple demo, I'm using a shared state in memory, nothing fancy. Of course, you can plug in whatever you want. You can plug in databases or whatever. So there are some crates available for out-of-the-box database inclusion, for database integration. This is what I meant. Then we start the web server, and here we see a bunch of interesting things. The Actix framework supports so-called middlewares, and here is one example of what you can do. You can plug in your own middleware, and in this case, I'm using the middleware feature to add the logger middleware. Then you can also share state, mutable state or read-only state using this pattern here. You just say, this is my state. In this case, it's an arc reader-writer lock across above a simple in-memory store, and you share it with all the different services. Then you can add services, as you can see it here. And these services, let me scroll down a little bit to see one of these services. You see it down here. These services have macros on top of it, and these macros define the route when the service should be called. So if you use this kind of call, you essentially base your coding on macros. There is also a macro-free variant. If you use the route instead of the service, you can specify the route directly here and then simply specify your handler function in this way. Then, of course, we bind it to a network socket, and then we simply run the server. That's essentially setting it up. Simple setup, but I think you get the idea. Writing the handlers itself is interesting. Here you see such a handler. The first point that I would like to point out here is this query thing here. These are so-called extractors. So you implement extractors that grab things out of the HTTP request. And in this case, I'm grabbing out an object which is defined in the query string. And with the data extractor, you can simply pull out of the whole of the whole setup. You can pull out the shared data, and then you can work with it. On the response side, you can simply create anything that implements the responder trait, so-called responders, and these responders are then going to be translated into HTTP responses by the Actix framework. If we scroll down a little bit, you see the concept is nearly always the same. Here you extract something from the path, and again, our shared state. If I scroll down again, here we extract something from the HTTP body. Pretty nice to read, right? So when you come from a different framework, you immediately feel at home. If I scroll down another bit, here is nothing special. The last sample that I created is this one, and this one writes something to disk. Simple JSON file, nothing fancy here. I wanted to show you how error handling works like. What you can do is you can return a result from your handler function. And in this case, I'm returning my own error type, app error. I can scroll up a little bit. This is my application level error object. Very simple here. Of course, you can add multiple enum variants here. And then you implement, if I scroll down a little bit, you implement the response error trait here. And as soon as your response error trait is implemented, your error object can be translated into a status code and into the error response, which will then be an HTTP body. In my case, nothing special here, just a little bit of JSON that I return. So you see, error handling is really nice. This is essentially, in a nutshell, how Actix works. let's quickly go back to the slides, and I will share my thoughts about ActiveSwag with you. It's easy to learn. Even if you don't know a lot of Rust and you just know other frameworks like Node.js Express or ASP.NET Core or Go Gin, for instance, it's really easy to know. You feel at home pretty quickly. I personally like the API and the programming model. Everything is typed, everything is fine. Documentation is available. You have a huge selection of examples, so everything is fine. It's granted not my personal favorite, but if I would have to build a project with it, it's perfectly fine. I will tell you which framework is my favorite. So, first one, ActiveSwag. Check. Looks nice, right? I like it. Next one, Rocket. This was, to be honest, the first web framework where I played with Rust a little bit. So Rocket is really near to my heart because it was where I started to code web APIs with Rust. So let's take a look at Rocket. A little bit about Rocket. It's well established and well maintained. It exists for many, many years. However, we are waiting for quite a while for the next non-release candidate or preview version, because the current version 0.4 is a little bit outdated, and the next version 0.5 is in release candidate, but already for quite a while. But that's perfectly fine. It works. You can use it. If it's okay for you to use release candidate work, it's perfectly fine. And the community is great in that area. So a big hand of applause for the community. It works great. And it's definitely feature rich. It includes particular good support for Diesel, if that is important for you. That's an ORM for those who don't know, an object relational mapper. And yeah, unfortunately, they don't have WebSocket support yet. It claims to be simple, batteries included, which it is, in my opinion. It's really simple to get started. They also claim it's fast. The benchmarks say they are a little bit slower than others like Actix and XAML and so on, but still it is pretty good here. So let's take a look at the second framework. Let's take a look again at a little bit of code so you get an impression how this looks like. This is now exactly the same API. You can try this API. I have some demo requests here. They all work, so play with it. Here, Rocket. Now, if we scroll down a little bit, we immediately see that Rocket is heavily based on macros. You see, I don't have a main method here. Everything is done by this launch macro. It generates a Tokyo main for us. Again, the log rate is used for logging. And if we scroll down a little bit, we see how it works. We mount the routes using a macro, as you can see. So all the different functions that you see here on the right-hand side are handler functions, and they are added, they are mounted to the Rocket server using this mount function and the Rocket macro here. This is how you share state with all your different handlers. You simply say manage and give it the shared state, and that's it. Now let's take a look how the handler functions work. And to be honest, if you have seen the Actix framework before, that will look pretty familiar to you, because the terms are a little bit different, but the concept is really similar. Here, we are talking about the from param trait, which allows us to get things from the parameters. Or here, you see something is picked from the query string. See that one? So you can implement you can implement the trait from param for your own trait, for your own types, and then you can use custom types. But Rocket comes with implementations of from param for all usual data types. So all base types, string, option, and so on works perfectly fine. Here, you see the state here. It's also something that can extract something from the request. And in this case, it's just, no, sorry, I have to correct myself. This is getting the shared state from Rocket, the thing that we first manage here. This is the shared state thing. On the response thing, here they also call it responders. Just like Actix, they have the responder trait, and you can return any custom data type as long as you have implemented the responder trait. Rocket comes with implemented responder traits for all usual data types. You can return a string, which will be a text response. You can return JSON. You can return HTML. You can do a lot of things. So Rocket is really complete and very easy to read and write here. If we scroll down a little bit, everything is perfectly fine. You see everywhere all these macros. It's heavily based on macros, and that makes it pretty simple. Even within the implementation here, for instance, I'm creating a to-do item. Even within, I see we use macros, for instance, to build the location header for the HTTP post request for the create request. So everything else is pretty similar. And here you see if you want to have a custom arrow object, Rocket makes it super simple to turn your custom arrow object into a responder, because they also include a derive macro here. So if you have your custom arrow type, just put the derive macro on top. You can have multiple variants of the enum, and then you specify what the result status code should be depending on the type of error. And then you can simply return the type of error and you are good. So again, by using the macro, the code is very clean and simple. Okay, you saw a little bit of code, and if you want to know more, take a look at my GitHub repository. My thoughts about Rocket. It's easy to learn. I personally think that it's even easier than Actix. So if you are an experienced web developer, getting into Rocket is absolutely no problem. I like the API. I like the programming model, but you shouldn't be allergic to macros. That would not be as good. So if you dislike macros, Rocket might not be the right thing for you. Documentation, 2 thumbs up. The documentation is available, very detailed, not just API documentation, but also conceptual documentation, large selection of examples. It's pretty easy to get started. And also, as of right now, the documentation is already on version 0.5. So you get not outdated docs, but really up-to-date docs, which include all the changes with the 0.5 version. Very good. So used it. I used it. I loved it. And I'm eagerly awaiting version 0.5 and the following versions. Hopefully, they will come pretty soon. That was Rocket. Next one, Warp. Warp doesn't have, at least I didn't find one, a great a logo for the project. So I used this nice little image here in the background. Warp. Warp is a little bit less active in recent times, and I have chosen it for this presentation because it is very different. It's very different from its approach. You will see it in a second. Regarding the speed, there are different benchmarks. Some say Warp is very fast. Some say Warp is in the middle. Take a look at the links here if you want to know more about benchmarks, if benchmarks are important for you. So Warp has a very different approach, and I would like to show you this code. Let's take a look at the Warp implementation. Here is the Warp implementation. As I said, take the time to take a look at my GitHub repo. You will see you can read a lot here and try and play around it. Now you see, same is true for logging, same is true for shared state, but then you immediately see that Warp works very different. Warp is based on filters. So what you essentially do is you use a single macro which contains a kind of domain-specific language for building the route, but from then on, everything is using filters. Here, for instance, you concatenate the warp get filter, which filters get requests. So the HTTP method get based on this base filter, which is derived from the path, from the route. And then you add another filter, which extracts an object from the query string. And then you add another filter, which wraps the existing filters and add a shared state. And somewhere at the end of all these filters, you're going to call your method. And this is the handler method. And then you define the next filter chain. You see it? This one is post. And we get something from the body JSON. And we again inject the state and we call the handler. And so on and so on and so on. And the API itself, I have to scroll to the right here, is essentially again a filter where you concatenate the different filters that I created before with OR. Because it can be the get request or the add request or the get single request or the delete request. I think you get the point, right? One important drawback from my point of view are the crazy types that you come up with. You see that? That makes it, at least from my point of view, a little bit hard to get into because these types are generic horrors. I wake up at night sweating and in fear when I think about such types. I'm not a big fan of those things. And yeah, I do Rust for a few years now, and I'm still afraid of monsters like that. And they also lead to a little bit hard to read errors. If you have an error that something does not conform to trait, and then you get 6 lines with nested brackets and so on, that makes me a little bit scared. So very interesting concept, very different from what you have seen before. The handler methods themselves are trivial. And that is the beauty of it. We don't need any extractors here anymore. Everything is type safe. So the filters up here make sure that the methods down here have the exactly correct signature. So if I change the filter and the resulting handler call does not fit to the signature of the handler function, then you get an error, you get a compile time error, and that is really beautiful. Of course, Warp also supports custom errors, as you can see it here. What you essentially have to do is you have to implement a marker trait or add a marker trait, and then you implement a custom so-called rejection function where you can inspect the reason of the rejection based on your error types, and then you can turn these error types into replies, which correspond to the reply that your API will send back. So again, different with this central rejection handling. So in general, this framework is very different from what you have seen before. So my thoughts about Warp, interesting, at least for me, intellectually challenging. I've seen quite a few frameworks, but Warp was really different. I personally don't like the programming model so much because of the super long and complex types, for me at least, which with just a few years of Rust background and not just doing Rust 24 hours a day, it's pretty hard to find mistakes. Documentation is available, but it is primarily API documentation. Yes, there are examples and they fill some gaps, but still on the documentation side, there could be more. So my thoughts, my personal opinion on that, it's just personal. It's not an objective opinion. It's interesting, but I wouldn't use it for a new project. Which brings us to my favorite, Axum. When researching for this talk, I learned that Axum is a city in Africa, a very famous ancient city. Look it up if you're interested in. Now, Axum is currently my favorite. I can spoiler that. It's rather young. But it is getting a lot of attention. New versions come out every few months. There is currently the version 0.5, but I'm already using the 0.6 release candidate version for this demo. And the most important and unique feature of Axum is that it heavily relies on Tower and Tower HTTP. So there is no custom middleware system. It's very much embedded in the entire stack of Tokio. You don't have macros. So if you don't like macros, you don't see macros, and it is fast. If you take a look at the Tech and Power benchmarks, they are pretty impressive. Want to see a little bit of code? Let's take a look at the code. So here you see Axum, and to be honest, I think we can go through that pretty quickly because it's if you know Actix, if you know Rocket, you will immediately feel at home when using the Axum framework. Let me show you. They use the tracing, Tokio's tracing library. So not the log crate here, the tracing library from Tokio. If I scroll down a little bit, you see I'm setting up a router. I share some state. This is a breaking change in 0.6. So if you are not used to this kind of sharing state, this is 0.6. In 0.5, it was a little bit different. And here you define the routes. You specify the get method, the pet post method, delete method, patch method, and so on. You can use Tower to wrap services around your routing, and you can add middlewares like that. Essentially, it works with any Tower compatible services. And then you simply launch the server. So if you are familiar with Tower and Tokio in general, then this will be your framework, I guess. And if we take a look at the methods, they are again very similar to what you have seen with Actix and Rockets. You have some extractors, as they are called here. Extractor for things from the query string, extractor for the shared state. Here you see an extractor, a JSON extractor which can pull out some data from the HTTP body. And the rest is pretty obvious. Of course, you can do application level arrow objects. And what you have to implement is you have to implement the into response trait for your application arrow object. And if you do that, you can easily return your arrow object directly here. Of course, everything is async, everything is Tokyo. So it is really, really nice API. I like it very much. Take a look. It's really awesome if you ask me. So my thoughts about XAML. Currently my favorite in terms of Rust web API frameworks. I love the API. I love the tight integration with other Tokyo grades. But again, that's just my personal preferences. If you see it differently, perfectly fine. And I'm absolutely aware that every project has unique requirements and every project is different. Documentation is there, but could be enhanced. It's primarily API documentation, pretty good API documentation, in fact, but they have a huge selection of examples, which help a lot when you take a look at XAML and you are learning. So if I would do a new project as of today, and I have a free choice of selecting my web API framework, I would probably choose XAML, but that's, again, just my personal thoughts. And what about the elephant in the room? WebAssembly. WebAssembly is great. I love WebAssembly. If you take a look at my YouTube channel, you will find me talking a lot about WebAssembly and the different application areas with Rust. So what about WebAssembly? Do we have frameworks for WebAssembly? Oh, yeah. There is one. It's Spin from Premium. I have done a little bit. I played a lot with it because I really love this approach. So let's take a look. Let's take a look how it looks like if we try to implement the same API using Spin, the Spin framework. Here is it. And essentially what you are going to do, let me show it here. You are starting with a TOML file where you specify all your WASM modules, and then you define the routes here. But do you see that one? I zoom in so you see it. See that one? Just 3 dots. That means whatever comes here, send it to the WebAssembly module. So there is no powerful router yet. Maybe there will be one. Maybe anybody wants to write one. If you take a look at the implementation, all we get is an HTTP request. It allows us access to URI, to body, and to path, and so on. But at the end of the day, there is no fancy router. We cannot store anything in memory. So we have to round trip it or save it to, for instance, a Redis server or something like this. I did here the round trip through the cookies, for instance. I save the database in the cookies. You have to do your own matching of the methods. There are no routing functionalities based on methods, for instance. You have to do your own error handling, something like this. You have to write your own extractors. So extracting, for instance, let's take this one, extracting an object from the HTTP body, you have to implement that on your own. Extracting something from the request here, as you can see it here, you have to do that on your own. So you see, a lot of potential. And this is what I want you to take away from this demo. It has a lot of potential for the future. What an awesome future. Using WebAssembly, running it everywhere, using WebAssembly components, being free to mix and match different languages. I'm really looking forward to that. But to be honest, it is a tiny bit too early for production. And that's it. So what are my summaries? So you have choices. If you start with web API development in Rust, you have a lot of choices. That's the good thing. Yeah, makes us smile, but you have to make a choice. If you compare that with other platforms, like for instance, .NET, which I use a lot, which I have been using for 20 years now, there is essentially one go-to framework. That's ESP.NET Core, and then you know what to do. For some people, that's an advantage. For some people, that's a disadvantage. For beginners, it's a little bit hard to pick and choose the right framework. Rust for web API in general, it definitely works. So if I compare it with Go, if I compare it with Node, there are very good options, and you have seen 4.5 if I count Spin 2 in this presentation, and there are even more frameworks. So definitely, yes, Rust can be used for web API development. Are we at par with other frameworks? I will take one that I know very, very well, ASP.NET Core. No. Absolutely not. If I think of the features that I get from these frameworks in terms of open API support, in terms of open API specification support, in terms of gRPC support, in terms of dependency injection, in terms of testability, there is a large number of features which differentiate these big managed frameworks from what Rust can currently offer. However, if you build an API where the unique properties of Rust are really important, for instance, top-notch performance, absolute best resource efficiency, a featureful language which is even more powerful than a long-established language like C#, then it definitely is a good choice to not switch to other managed platforms and build your API directly in Rust. And the most important thing, it's fun. It's fun, it's enjoyable, I love it, I love working with it, so try it. If your next web API is around the corner and you're thinking about whether you should use Rust, definitely try it. I think it's worthwhile. And with that, I am through. If you would like to take a look at my source code, take out your phones or write down this GitHub URI down here. There you also find a link to the slides, and you can take a close look at my GitHub repo. You can take a look at my code and get your own impression from how these different frameworks work.